Hey, what's up guys, my name is Cherno. Welcome back to my code review series, a series in which you guys send me your suspicious projects and I take a look at them. Today, we are doing something a little bit different because I saw this email come in. Game made in Hazel for Ludum Dare, and I just couldn't resist. So this comes from Neff. Hi Cherno, longtime follower here. So I recently participated in Ludum Dare 57, which was like a couple months ago, I think. But I wanted to make things interesting. I was fed up with Unity. Godot is good, but not really for me, and I won't even entertain the idea of using Unreal. I feel like Unreal's the best option of those three, but okay. So I wanted to make it in a more experimental underdog engine. Is that a compliment? I don't know. And what better one than Hazel? No complaints from me. At least if things get tricky, I can move to Unity pretty easily. I thought he was gonna say, at least if things get tricky, I can ask you for help. So I made this game called The Fall. I have 0 art skills and I was a bit busy with work, so I'll admit this is not my best work, strong start, but I thought it might be fun to see how someone uses your own engine. Yes. The engine version is 2024.1 stable in case you end up running into issues with a dev version. PS, I tried to add sound, but I couldn't find any videos explaining the sound graph and it just didn't work for me. And then here's the source code. Okay, so pretty exciting. I don't think I've ever code reviewed a game that was made in Hazel, not by the team. So I have technically done a Hazel game code review because like a few years ago, Tim, who was still on the team back then, made this Space Invaders clone. And so we had this like hour-long, really chill code review where I just went over everything with him actually in the video and basically told him my thoughts. However, one of you guys making a game in Hazel is not something I've ever reviewed. So I am pretty excited to take a look at what on earth this is. So for those of you who don't know, Hazel is a game engine that I've been working on for the last few years, and recently I made a video announcing that it's going to be free, completely free to use very soon. Even though it hasn't officially been released just yet, you can still sign up on patreon.com/thecherno and get access to all of the source code, all of the development repository, all of that stuff, and actually start using it immediately, which is what this person here has done. I have been getting a lot of requests from you guys to actually make videos showing how to make games in Hazel, but I'm more or less waiting until that free, full, stable version gets released, because first of all, that's obviously going to greatly increase the target audience size for those videos, but then we're also getting to a place where Hazel will be a lot more stable, a lot more usable, and I'm not going to have these obsolete videos, these outdated videos on the channel that I'm going to have to update and remake anyway with the new version. So if you do have access to Hazel, and I will leave a link to this repository in the description below in case you want to check it out. Again, 2024.1 was the version of the engine that Neff has said he is using, so that's what I've got over here, checked out, ready to go. Without further ado, let's dive into the repository and take a look at what we have here. So first of all, a couple of things I'm noticing just by looking at this repository is there is no README. Again, I say this pretty much every single time that there is no README. There should be a README that just even shows like a screenshot of this. I mean, presentation is really important, but also maybe some build instructions, just like some information about the game, like just really simple stuff. Just have some information about what this project even is in the first place, how to get it up and running, and show it off in a screenshot. It would have been nice to actually see the Ludum Dare submission page, assuming that was a thing, like assuming this person actually did submit it as like a Ludum Dare game, and also was it built using the runtime or not, in which case are there pre-built binaries that I can just play, or was that something that Neff didn't know how to do? Like, I don't know. But that's step one. Step two is resources scripts intermediates. As the name implies, none of this stuff has to be committed. These are just intermediates. They're not even binaries or anything. So definitely don't commit this. And also I'm suspecting in assets and probably scripts, binaries and intermediates debug. These also can just be added to the git ignore along with this obj directory, which is also like intermediate. Source is like the only thing you need here. Oh, it looks like there's quite a bit of source here. That's nice. It's not just like, cause I don't know what to expect from this. This could be just like a really tiny game. We'll see. Lots of different assets. It seems. Is there stuff in like models and meshes? Yeah, it looks like a decent amount of stuff. There's a bunch of FBXs and GLBs. So we'll have a look at this inside Hazel and see what we can do. Now, as always, you guys can submit your project in for review by emailing it to chernoreview@gmail.com. That email address and some instructions will be in the description below. However, if you can't get me to review your code, then you should get CodeRabbit, the sponsor of this video, to review your code instead. CodeRabbit gives your code AI-driven contextual feedback no matter what language you're using. It integrates with GitHub and GitLab and scans your pull requests in real time as they're coming in, showing you potential bugs, security issues, and helping you improve your code in general. Now, my favorite way to use CodeRabbit is in VS Code using their extension. CodeRabbit can also integrate with other IDEs such as Cursor and Windsurf. This way, before we commit our code, we can actually get CodeRabbit to do a code review over it and point out potential mistakes or just give us suggestions like any other fellow engineer would do in a real code review. So to give you a little bit of an example of what CodeRabbit is capable of, check this out. One of the potential issues that is picked up is that we have this duplicate operator over here when this define is enabled. And it's able to track that down because this specific define, which used to just be in a CPP file, is now defined globally in premake5.lua. So it's actually looked at the premake scripts, the build scripts, and seen that that's now defined there. And as a result, we may end up with a multiple definition or redefinition error, depending on what kind of modules we actually build this code in. And I think that's really cool. Just the fact that it's able to look at your project as a whole and see things like this makes it so much more powerful and useful. And the best part is that CodeRabbit is completely free for open source projects, or if you have private repositories, you can give it a go with a 14-day free trial. Just go to coderabbit.ai, link will be in the description below. Huge thank you to CodeRabbit for sponsoring this video. Okay, so Hazelnut, which is the editor, I'm gonna build in release. That's all I'm going to do. And again, this is 2024.1, not like the current up-to-date dev repository, which is not expected to probably work with any of this stuff. Over here on disk, I've checked out the repository. We have the full solution file, so I'm gonna open that as well. And this is the hproj file. This is like the Hazel project file that we now need to load inside Hazel. So let's just not show that again. So file, open project. We'll go to this path and we will open up the full.hproj and hopefully this opens. There we go. We've got something. Oh, this is interesting. I haven't looked at this project before, so we're gonna have to take a look and hopefully it's gonna be straightforward because I don't know, everyone sets up their games a little bit differently. Obviously, Hazel's a very flexible engine as well. So it's gonna be interesting to see how this is put together. Space to play. Got a bunch of entities over here. All right. And then we got obviously the solution file. So debug release doesn't really matter for these C# scripts. I'm just going to build these and there we go. Everything's built. Hazel will actually build these scripts for you, but I just wanted to make sure that everything compiles. And then we've got all of the files over here. So I'm guessing the first thing I should do is probably try and play the game. I have no idea how to actually play it. So if we hit play and then I guess we press space to play, I guess we'll fade into something and then we're falling. Okay. I think I'm controlling the leaf. Oh, is that supposed to be wind? Okay. So I can, light fades from us, press space to replay. So I think W and, sorry, A and D, so like the WSD keys, but I don't know if W and S does anything, no. So A and D looks like it moves the leaf, I guess. I don't know what my objective is at all. It would be really good to have some instructions on like how to actually play this game and you know what the objective is and what the controls are. Are those all the controls? I can't see where I'm going anymore. Is that because I didn't pick up enough light? I'm guessing I'm supposed to pick up the light phase from us all. So do I lose if I run out of light? And I guess these are the light things that I can, okay. And then that's just like fading over time, is it? So I'm trying to pick up these lights. Okay, that makes me brighter. No way I can get there with the wind. There's no light for me to pick up. Oh, here we go. Oh, but if I hit that, do I lose? Okay, I'm gonna quickly have a look at the source code because this doesn't really do a good job of explaining how to play the game. So let's have a look at, I'm just gonna do a search for input and see, oh, space does something. What is the space? Oh, that's for the main menu. Okay, A and D, yes. Oh, look, there's a if input is mouse button pressed, mouse button right, trigger the dash. Okay. In the relative direction of the mouse. So you can dash with the right mouse button. Okay. And then how do I, see this is a bit ridiculous, obviously, the fact that I have to like look through the source code to figure out how to play. But what I am interested in as well is how I lose. So I'm guessing game manager, let's have a look. The code is actually pretty clean so far. Like I'm, terminate game. So game over equals true. M license. So when does this get, there's one reference to this in here, and that's if distance to player between what? The player and this obstacle object is less than the detection radius, then we end the game. Oh, detect if we hit the player. So I'm not allowed to hit obstacles, apparently. Maybe that was the issue. Okay, let's try, oh, whoops, it doesn't matter. Let's try play again, and then I'm going to, I guess I can dash. Oh, that's a dash with the right mouse button. So if I hit that, I lose. Yeah, okay. So I can't hit obstacles. I don't think light matters at all. It's just that obviously I can't see if there's, oh no, I'm definitely gonna lose. Oh. I don't think light matters. I think I just can't see, obviously, if there's no light. So therefore, how am I going to dodge the obstacles? For example, here. Why is there no more light spawning? I really have to pick it up. Maybe it stops spawning if you miss it. And it looks like with the dash, I didn't actually hit anything there, I don't think. What are can I see the physics colliders? I'm going to go to the viewport settings up here and actually show, all the physics colliders. Okay, so that's the leaf collider. And there's all these, I wonder if they're just, I don't know what they are. I want to see if the colliders are like super big or something. That's got a sphere collider on it. can't even really see that. Never mind. Okay. Whatever. That's the game. We're a falling leaf. We collect light. There's wind and there's this particle system, I guess. And you're just trying to survive, I guess, for as long as possible. But there's no score or anything. So fairly primitive game, of course. Not too much going on here. Definitely could be refined a lot more. But hey, it's made in Hazel, so I can't really be too harsh on it now, can I? We got this like very interesting looking. What is this? Very interesting looking main menu setup. And I guess it's like these are trees or something, and then we kind of jump in the tunnel or whatever, and then we're falling into the thing. So that's interesting. So I'm guessing we've got two scenes over here. If we have a look at the scenes, we've got the menu and then we've got main. So if we look at the main scene, this is the main scene. Okay, so this is what it looks like. So we've got the leaf, we've got a light, we've got this, and then I'm guessing these like walls. There's only 2 walls here. I'm not sure why it's not highlighting them, like to show what's selected, because it shows the leaf, but this wall, it's not highlighting the mesh. I don't know if that's because it's like really big, or that's very interesting. Weird. Okay, and then this environment tray, whatever that is, has a bunch of lower bounds and upper bounds. That could just be, let me just show. So with the physics colliders, I can also show just the selected entity. So that might help if we actually want to see if they have bounds. But here's well walls. These walls are different, I guess. They're also kind of at the origin though. They're these ones. Oh, hang on. Static. It's not visible. I'm a clown. It's not visible. So I guess this is just being used as like a collider, but it's got a box collider on it. So this is a bit, you don't need the static mesh here at all. I mean, it's not going to render, so it's not using up too much performance, but still having this is a bit redundant, because if you were using it as a mesh collider, then obviously that would kind of make sense, but you don't actually need the static mesh component for that. Because if you use a mesh collider in Hazel, then you can just, usually you can specify which mesh you want to act as a collider, but maybe not though, because no meshes are coming up here, which makes me think that it's a different asset type. But anyway, obviously, yeah, static mesh is just like for rendering, and then box collider, if you have a box collider, then you don't need the static mesh on it. Now, if you have a collider with no rigid body, it's going to be a static rigid body by default when it gets like when the scene actually starts. But otherwise, if you want to override parameters, then you can also add a rigid body and configure things such as like what physics layer you want it to be on and stuff like that. Okay, so that's what those walls are. And then environment, well walls. Well walls are these things. And then we've got like these wall segments, which I'm guessing kind of the script will probably either move them down or spawn more or do something as we drift down. Now for the actual player, so it's got a box collider on it, it looks like. It's got a dynamic rigid body, so it's using Hazel's physics system, as you probably would expect, to make it fall downwards. We've got some, what does this look like? Mass 1. Yeah, so like, I don't know. Obviously this is very subjective. You can tweak physics parameters however you like. This is basically like in kilograms. So 1 kilogram is a little bit heavy for the leaf. So if you want it to be a bit more floaty, maybe you could make it way less. So when you're making physics for a game, especially a very abstract arcadey game like this, it's not really like the goal isn't to make it like a simulation necessarily. It's just whatever feels good and whatever is good for gameplay effectively. So it doesn't really matter like that this weighs 1 kilogram. If you kind of control your forces in such a way that that feels good to you, then these numbers don't really matter. They're just numbers. What you're trying to do is obviously create like a good feel, and that takes a lot of time and a lot of expertise and a lot of like testing to get right. And that's obviously very difficult to do in a game jam. So that's why a lot of game jam games end up not feeling very polished, because that polish stage can take a significant amount of time. And, you know, in a professional game studio, you'd get so many different people to come in, try and play it and be like, oh, this feels floaty, or this feels too rigid or too slow, or it doesn't accelerate fast enough. Like there's so much feedback and there's so much iteration that can happen for the way that gameplay feels, because it's like the most important thing, probably one of the most important things, especially like for the main character, you know, which is this leaf. Refining how that feels can just take so much time. So yeah, very, very difficult to do in a game jam unless you kind of know what you're doing already. Like meaning that like you've been through it before. You are making a character that you in an engine that you're familiar with, and you know like, oh, these parameters work really well, or this is a good baseline, this is a good template to start from. Then I can kind of tweak and refine as I go. Okay, cool. So anyway, I think we've looked enough at the actual structure of the game within Hazel. I think the code is probably what more people are interested in. So let me just close everything over here, and then we're going to start by looking at, we could, by the way, look at, if we look at what was like this leaf, for example. So you can see that this has a script component. A script component in Hazel is how we actually tie an entity to a C# script and have that C# script run. So you can see that in this case, it's tied to leaf movement. That's the script class. And then leaf movement is going to have these public variables inside the class. So if we have a look over here, that might be a good place to start. This leaf movement script, which is its own file over here. You can see it's got these three parameters: public float speed, and dash duration. And those are all things we can set here. So it's cool to see people using Hazel more or less properly, meaning that like, because there's very little video tutorials or like just educational content surrounding how to use Hazel, the best examples are probably me using Hazel or the team using Hazel to make Ludum Dare games, but a lot of those are like somewhat outdated as well, so they're probably not the most relevant to, you know, Hazel 2024.1, which is like the latest released kind of stable version. So that's why if you hear me say stuff like, oh, that's not how you are supposed to do that or whatever, I'm not throwing shade at the author of this like whatsoever. It's actually quite impressive to me that they're able to make something like this, because there's so little documentation, as I mentioned, out there, that it's like, how are people even supposed to learn how to use this engine? You know, well, they're not really at the moment. It's very experimental, very early stage at the moment. When it comes out, we're going to come out with like a lot of documentation, you know, when it's free to use and everything. And that will, like, I'll make video tutorials, and I'm sure other people might as well. So it'll be like a lot more straightforward. So at this stage, like, I'm just impressed by the fact that, oh, cool, we have like public variables being used here. Not everything is just like hard coded inside the actual C# script. Of course, this is similar to how Unity does it. In this case, it works exactly the same way. In a way, our goal with this is to try and make it as intuitive as possible, and there's a lot that I like about Unity's workflow. I think that, you know, that way of kind of making games where you've got like the editor working together with all the code and it's C# and everything can, I just like that. I think it's a really powerful way to make games. So stuff like that, I definitely am trying to keep. That's why like a lot of the API as well is quite similar, you know, between Hazel and Unity. Okay, so what we are looking at here is just a pretty typical, I would say, game script. So this is an entity. This is a Hazel entity, and so because of that, it's going to have some methods here that we can override, such as on update, which will be called every frame. On physics update is even being used here, which is cool. That's going to be called on every physics update, which can be independent to the frame rate. And then we typically also have like on create, which is up here, and then there's on destroy, and there's a bunch of functions really. If you go to the entity class, if you have no idea how to use Hazel, you can always look at the like existing codes. So if you go to the entity class, then you'll see somewhere like over here, we have a bunch of these functions that are all virtual that you can override if you wish to have them called at certain times. And then there's also like these events, these actions that you can hook into if you want to be notified, like for example, when there's a collision between two entities. So that's kind of all listed over here. All right, so when we create this leaf, this is all pretty standard stuff. This is being used a lot. I guess this is just intentionally a stylistic thing. Obviously, it's not required. I personally never write this unless it's required, which when you're referencing stuff within this class, like it's not required unless you have a conflicting name. So obviously, if I have a local variable called A, and then I also have a variable up here called A, and I want to refer to the one up here, then I have to use this.a. So you'd have to do something like this in order to actually specify which variable you want to refer to, because they're both called A. If you don't have naming conflicts, which you shouldn't, especially if you're using this M underscore convention, which further defeats the purpose of having this qualifier out here, then obviously you don't need to do that, and you can just write your code like this. Especially weird is using it in front of functions. So because there's nothing else this could possibly refer to. So that's a little bit strange. Get components actually on the base class anyway inside entity. That's like the first weird thing that I'm noticing. There's even an assert here, which is kind of cool. So we're just making sure that we have a rigid body component. One other thing you can do is use the has component function if you want. That way you could do it kind of more or less runtime. Asserts are also runtime, but they're not really like recoverable from. Whereas if you just wanted to have like a bunch of validation checks at the front of this, for example, then I would probably just assert has component, rigid body component. Okay, so just setting up stuff over here inside on update. If it's game over, we return. So I like to drop these down here as well. So this is all pretty straightforward logic. Good to see time step being used as well. A lot of people seem to have issues when it comes to timing, or being like, I don't want to say aware of time, but a lot of the times in your game, see what I did there? A lot of times in your game. A lot of the time in your game, you want to tie things that happen in the game, like logic, to real world time units. So in other words, I want this to take 2 seconds, or I want this to be 5 milliseconds. Timing is something that lots of game engines and APIs try to cleverly, maybe even use things like coroutines or like, lambdas or whatever it might be to notify you and try and chain like events together into timings. So like, for example, in Unity, we have like invoke, and then you can actually pass that in with a time. So you can invoke, actually it takes in a method name by string, which is weird. But anyway, we can invoke like this launch projectile after 2 seconds of like real world time. So it's delaying like that function call effectively by a given amount of time. There's lots of different creative ways to solve this. Hazel doesn't have too much built into the actual like C# scripting API. Of course, you can build your own tools because it's C#. So whatever you might want to use, whatever libraries you even want to hook in, you can do all of that, which is great. It's more or less up to the game maybe to add all of that complex functionality. Although we probably will try and provide obviously as much as reasonably possible to make stuff easy if you're working on like sandbox and like small projects and you don't want to have to hook in so much extra third-party code or do a lot of writing yourself. However, all you really need to know with timing is that you have this glorious time step parameter, which is like your delta time. So it's how much time in seconds has passed since the last frame. And so because of that, it's really, really easy to, for example, set the dash cooldown to, well, in this case, I guess it's being set to 0.5 seconds, right? Because all the time units here are seconds. So if you want milliseconds, you have to multiply it by 1,000. But we know that the dash cooldown is 0.5 seconds. So therefore, if we have our current dash timer and we just subtract time step from it, like we are doing here, for example, if we set it to 0.5 and we subtract time step every frame, then no matter how long that frame takes, because each frame can take a different amount of time, and in fact it will usually, we know that we're decrementing that timer by how much real world time has actually passed. And that's effectively all you need to know. Because if you want to count upwards, for example, you're just going to add that time step. If you want to subtract because you have a timer that starts at like 2 seconds and you need to be aware of when it reaches 0, then you can do something like this, where you just subtract it, for example, every frame. Well, in this case, it's subtracting it if it's greater than 0. But the way that I generally do this is you could have something like dash cooldown time minus equals TS. And then if that dash cooldown time is less than or equal to 0, so you've basically hit 0, it's possible that you went a little bit over, because obviously this is not like, this is usually something like 16 milliseconds, but obviously expressed in seconds. We're not calling this every like nanosecond. So obviously you might be a couple milliseconds over or something. If it does hit 0, then you can basically do your action and then, like, for example, reset it back up. So dash cooldown time could be reset to that dash cooldown parameter, which is going to take it back up, and then you can do your dash, for example. Obviously that would also be tied to input in this case, but that's basically the general idea. So it's nice to see this being used over here. This is my preferred way of handling things like this. In a more complex, refined game that obviously isn't made as part of a game jam or just has a more extended API or library, you could have a system that does this for you so that you don't have to actually keep track of all these timers. Because the downside with this is if you have like 100 things that rely on timers to happen, then obviously you're just going to keep adding these floats and like the current timer, the reset time or whatever. Your on update function is going to be like 100 lines long because you're doing all of these timers one by one. When it gets to that stage, we are software engineers, so we start to think about, hey, what if we had a system? What if we had a dedicated system where data goes in, data comes out, that actually handles that transformation of like these seconds being decremented or whatever, and then we could maybe ask for the parameter that we're looking for, or even have callbacks and get notified when certain timers go off. Like, that's where the engineering comes into it. But at its core, this is as simple as it really is. And obviously for a game jam, we're trying to keep things as simple, as manageable as possible, because otherwise we're kind of wasting time potentially designing and implementing these systems, which, even though they might sound simple, they're probably also going to need like some testing, some design time. We might change our minds. We might realize, oh, this doesn't actually work with this game. We don't want to be dealing with all of that stuff if we are fairly sure that it's going to take less time for us to simply write something primitive like that. So that's actually one of the reasons why I really like game jams. And, I used to love not using engines at all. In fact, most game jams that I've done in my life, up until Hazel started getting more or less mature and ready to make games, like all of those were basically from scratch. Like I would use, not like completely from scratch, but I would use some framework, or I would never use like an actual engine. I used to use Java a lot and just, not even like OpenGL or anything, but just Java and the included Java library and render pixels to the screen. Very very, very primitive stuff. And even though that meant that I had to basically write a little bit of an engine, a little bit of infrastructure, a little bit of a system to get the main things up and running, it was that like from scratch primitive way of doing things that I think taught me a lot, and also was just really fun to use, because then you get back to your real projects that are not game engine games, and those are obviously much more complicated in the long term. So it's nice to just kind of go down to this primitive level, keep things simple, and actually try and focus as much as possible on the actual gameplay and the logic and getting all of that working. I think the idea and all of that is kind of, you know, I mean, I was going to say that's the purpose of the game jam, but I think that every time I do a game jam, I usually have a goal. Like I want to refine this system in Hazel or something, or I want to test out this new technology, or I want to try and implement this. Like the goal for you doing a game jam can obviously be whatever you want it to be. And I think there are obviously so many like viable goals or so many things that a game jam can really help you actually test out and prototype. But anyway, I guess in conclusion, my point is just that this kind of primitive way of doing things is nice, and I like to see that in game jam games. I guess I'll also point out that that's not to say that you shouldn't use a game engine or anything for a game jam, because for example, if you want to make a 3D game, or if you have this vision of like, I want the game to look like this, then there's a big chance that you're going to need a lot of technology to make that happen. And by using a game engine, whatever it may be, you know, Hazel in this case, you have all of those tools already available, and you can focus on making the actual game itself, because you have such a small amount of time anyway that you only really barely have enough time probably to spend all of your time on this one idea and getting that and making that actually happen. Then if you had to also build a 3D game engine on the side, then you're not going to actually get to doing the thing that you want to do. So of course, use whatever you want, but when it comes time to getting scripts to actually like do what they need to do, it's nice to see like no over engineering being done in this case. Okay, so on physics update, so we're doing mouse stuff here, which I guess is fine. Then we're calling this move. We've either got move or dash, and then move is going to just add force. So we're just adding like normal forces here, which is pretty standard. There's different types of forces that we have available to us as well. There's impulse, velocity change, and acceleration and of course force, which is the default one. So it just depends how, I guess, urgent you want to be with your force. So for normal movement, it's probably okay to just use normal forces. If you don't specify a parameter, then it's going to be force by default. That's just going to take a little bit longer to kick in, which is going to give you that like natural acceleration that you might want from here. Dash, I would probably expect to just have an impulse force, but interestingly, what it's doing instead here is actually setting the linear velocity immediately to this. So that kicks in like that, obviously, because it's like suddenly the leaf's velocity has been increased, you know? I don't know if that's, I'm not a huge gameplay programmer, but I don't know if that's the best thing to do. And interestingly, it's happening here as well. We're adding force over here, and we're also clamping linear velocity to max velocity. So one thing that we have inside the physics system actually is the ability to set a max velocity. So you can see that we have a max linear and angular velocity. So you can actually just set that to what you want and not worry about the clamping. So that's probably something I would do over here. The problem with setting velocities directly is that sometimes this can bypass physics. That this used to be a big problem with NVIDIA PhysX. So back when Hazel used PhysX, we had a lot of issues when we tried to control like things like velocity ourselves, because it would basically get it into a state where that velocity would bring it into being intersecting like with another physics object, and then we'd get stuck in it or something like that. I don't know if Jolt, which is the physics engine that we currently use in Hazel, if that's the same, gonna have the same consequence, but generally I would avoid, you know, setting velocities directly and instead use the add force function either with an impulse force if you want it to take effect a lot quicker. There's also velocity changed, by the way. So like if we go back to where we add force, then you can see that there's a force mode called velocity change, which ignores the object mass basically and just immediately like gives us a velocity change as it implies, but at least this way it's taking into account the current situation of the object and all of that. So I just assume that would be a little bit safer, but again, I don't think I've done exact tests like this with Jolt, so that would be interesting to experiment with. Okay, and then for handle input, we just set moving direction over here, and I'm guessing that's something that we then end up taking effect inside the move function from on physics update. Cool. Okay, so let's have a look at some of these other classes. I'm expecting a lot of them are obviously going to be called from like various entities that we might have here. So like environment tray, whatever that means exactly, has this script class called environment tray, and then it's got a bunch of stuff. So this is actually a really good example, I think, this environment tray of, you know, how I like to use scripting. Okay, well, not quite, but It's along the same lines. This is like a really good example of how I like to tie in C# scripting with an actual visual editor, you know, when you're making a game. And that is, you want to lean into the fact that the editor provides you like this visual 3D scene that you can actually design. So for example, we need like an upper bound and a lower bound. We could try and just define that by just values, by numbers in code, or we could create an empty entity. So by empty entity, I just mean that we have this entity called lower bounds, which has nothing in it except for its transform. Every entity has a transform, and in this case, it's actually parented to environment tray, but that doesn't really matter too much. We have lower bounds, and you can see it has values in it. But the difference is that even this object, which doesn't have a mesh, doesn't have any kind of box collider, it's just this, it's a point really in 3D space. We have it in 3D space. So it's like over here. Usually one thing I might do is add like a debug mesh to it just so we can see it inside the editor, but whatever, we can see it by its gizmo. It's over here, and then upper bounds is all the way up there. So by having these empty entities and just like being able to obviously, you know, drag them around, move them to wherever they need to move to, just by having these, 3D points basically, and being able to visually define them, you know, inside the editor is a huge help. And then obviously you can see these upper bounds and lower bounds entities. They've basically been, you know, dragged in like this over here, and then we can access that entity from within this environment tray script class. So if we go and find environment tray, you can see we have these two entities, upper bound and lower bound, and then we're able to actually use their translation in the code. So that's a really nice synergy between the editor and the scripts, the behavior, the logic for the game. Another great example, which I thought was happening here, is things like box colliders. You know, if we wanted to have like a spawn region for something, like let's just say we had those forces. Actually, I wanted to have a look at how those forces work, because we had those, by forces, I just mean like the particles that we're shooting out. I suspect we'll find them a little bit later. Well, actually, here's wind particle system prefab. But for example, this is different because everything's falling, so it might be a little bit difficult to actually define like fixed locations. But if you had like a spawn region, like this huge box, which entities could spawn like within, you could define that by just having a box collider. That way you can define it visually inside the editor, and then when you're inside like your script, you can just reference that entity with its box collider, with its bounds, and then use that as the spawn region instead of obviously having to like specify numbers inside your code, which very difficult to visualize. So try and lean into the visual aspect of the editor and tie that into the code. That's generally what I think is just really, really strong. Okay, so the other thing that this has, by the way, aside from obviously like a float value, entities, this is almost like a little Hazel demo. It's got everything. It's got prefabs, which is cool because prefabs are basically entities or entity hierarchies even that we've created ahead of time. So you can see there's quite a lot being used here, and we can instantiate them dynamically at runtime using this script. So you can see that, for example, we have these wind particle system prefabs, and then when we have the spawn wind effects function being called, which I guess has a random 1 in 10 chance of actually not returning, so therefore spawning a particle, we can go ahead and call this instantiate function on the entity with that prefab, which will actually spawn the prefab at this position in while space in this case. And you can see it's even using the .as function to cast it basically to a particle system. The reason why, so yeah, this is actually pretty cool. This is, I would say, a fairly intermediate to advanced usage of Hazel, which I didn't know was possible without basically being on the team because of our lack of documentation and educational content. So I'm definitely impressed. But anyway, so we have like this wind particle prefab. So if I just drag that over here, we can see it. Let me hide the physics collider. So that's what it is. I guess it's just like one of these or something. You can see that it's actually got a script attached to it. The script is called particle. So that's why we're able to, oh, that's not it actually. So wind particle system prefab. I guess that's probably, I think this is just a single particle, but then we have, yeah, here it is, wind particle system, which doesn't have like a mesh associated with it, but it does have this particle system script. So because this prefab actually has a particle system script attached to it, it means that if we spawn it and we instantiate it like this, we can use the .as function to basically treat it as this particle system script, which is an entity. So we're basically just making sure that, okay, we're going to immediately reference it as its existing class so that we can then obviously access the functionality of that class and, for example, set like this callback to destroy this specific instance of, well, this is just setting like a function, so the instance actually gets passed in by the parameter over here. So this definitely didn't need to be created here, but anyway, we can start like this wind particle system, you know, right from here. So this is pretty cool. This is exactly, I guess, how I would do it in terms of like Hazel's API usage and everything. I think that's good. And then this is like the actual particle system, I'm guessing, which is itself an entity, and then on update, I think it will just animate the particles basically. Where are the actual particles though? So when they get spawned, like, are they contained within here? So we just have, it looks like one particle here, but how do we create multiple particles? So I guess this is what happens. So when we do on update, okay, right. So it's got some sort of duration that plays the particle system, which I guess just allows them to get created. And then every single frame, maybe cache these. Yeah, where are they going? That's potentially worrying. But anyway, every single frame, we go through and we instantiate this many particles, and then they've actually got scripts attached to them on which we call init. So that's why when I dragged in just one of these particles, so here's one particle, it's also got a script attached to it, and a dynamic rigid body and everything. So yeah, this is obviously not great for performance because where every single particle is an entity with a C# script attached to it and a dynamic rigid body. So definitely not the best. I don't know why it necessarily needs to have rigid bodies or C# scripts attached to it. So an individual particle, I guess, is responsible for basically controlling itself. So I wouldn't really do it that way. The way that I've always done manual particle systems, because Hazel doesn't have a particle system at the moment, but it will probably have one in time for like our full free release, as I was talking about. But because it doesn't have a particle system at the moment, it basically means that you have to implement one yourself if you want particles inside like C#, for example. So that's usually what I end up doing pretty much every single Ludum Dare game that I make, because particles are very useful to have. But usually what I do is I just have like a struct or something of particles that are stored within a list inside like a particle system entity. And the particles themselves are not entities. They're just like little structs of data that just have all the relevant data to it. And then I get the actual C# code to basically render them. Or actually, maybe the individual particles are entities, but either way, they don't have C# scripts attached to them, which need to be individually updated, because that can be a huge slow point. What they are usually, which works rather well, at least with Hazel, is that each individual particle is a prefab, which can have things like, you know, a sprite renderer or a mesh renderer component on it if you want like a 3D particle with like, you know, you slap on a material, you visually dress it up to have it be good and have it be like what you want it to be. Then you make a prefab out of it, and then you can instantiate that prefab inside a particle manager script, and then maintain like the list of those instantiated prefabs inside that script, store them in like some kind of container entity if you want, so they're all parented to that. And that way you can basically animate their position, process all of their behavior, all within like a for loop inside your particle manager script. So they don't individually need to have C# scripts that have like an on update function that gets called on them, because that can be, you know, pretty slow, especially if you have like 1,000 of them. But having like 1,000, even if they're 3D meshes, like just 1,000 instanced meshes that the engine has to go through in Hazel is not too bad, especially if it's not on the screen like at all times. So that's an optimization that I would probably make. But again, what I usually do is I have like a little particle system C# script that's ready to go, like, and then I can just slap that in. You know, I wrote it once, you know, I can just slap it into any Hazel game that I make, and then I know how to use it, you know, to create like some container entity for it and some prefabs that I want to use with it. And then it gives me a bunch of parameters that I might want, like scale, you know, animating over time like it is over here, without having the need for each particle to be its own like C# script, because that can be slow, or at least slower, because obviously we didn't have any problems with it while playing on this computer. And this computer, by the way, this is my code review computer, as you probably saw from the intro. So this is like, I don't know, a Core i5. It's got a 3060 in it. This is not a very beefy computer by any means. All right, and then like a light pickup. So I'm assuming that like when we pick up stuff, we probably have we must have some way to detect collision with that. So I'm wondering how that's implemented. Oh, okay, it looks like it's just done very easily. I guess that's fine. I would probably just do it using, I guess, the included functions, just because that's even easier and maybe a little bit cleaner because you have like those dedicated functions for it. But this is very, very simple and probably faster. I mean, the physics system knows when collisions happen anyway, so I don't think it would be a much greater cost at all to just like ping C#, you know, a callback being like, hey, there's been a collision over here. However, what this does is it basically grabs this is the leaf. I think we're inside the light pickup. Okay, so I'm guessing this is like the current light or something, but this is coming from the player, right? So this is the player's position, and we're just measuring the distance between 2 points. So we have like the light over here and we have like the player over here. And we're just like, okay, what's the distance between these two? And if it's less than this pickup radius, and obviously the light is a circle, so it kind of means that you can just use the radius to that. If it's less than the radius, then we're just like, okay, we've touched the light, we've picked it up. So that's the most simple way to do collision detection in all of like games and collision detections, is just basically the collision of two circles. Because it's just like, okay, what's the center point of the circle, and then what's the radius? If those two are greater than like the other one or whatever, then we're colliding. That's what's happening here, but I don't think the player even has a radius. We're just like, the player is just a point in this example. So it's just like a red point. The light has a point plus this radius in orange. And it's like, okay, if this red point becomes somehow inside this like circle with its radius, then that's true. And then we do that. So very, very simple and definitely consistent with the game jam theme. Okay, cool. I mean, we've got some like static functions here, which could potentially be questionable. So what does this actually do? It just goes to game manager instance and it spawns one of these light pickups. Okay, and then entity spawn tray is probably, so game manager is quite a big class as well that we didn't look at, but this is all pretty straightforward, I think. It's just like logic. We've got a lot of assets, which is nice, just making sure that our state is what we expect it to be. Here we see some scenes being loaded, so we can load other scenes in Hazel. This is just how we go between like the game scene and the main menu scene. We remove all the light entities and everything. What happens on game over? Do we, yeah, so we do actually reload the game scene, interestingly, right? So we remove the lights immediately. So remember, this is still happening every frame. So as soon as we've lost the game, we're in this game over state, but we're still updating every single frame because it's not like the application has ended, right? And so we're just in this block. So we remove, I mean, we're trying to do this every frame, but I guess once it gets removed, it's not going to do anything. It's only going to really run the first time. And then it sets all of this stuff up and then it keeps doing this every frame, but it's basically just waiting for us to either press escape or space. And as soon as we press one of the two, it's either going to reload the current scene by just triggering a load of the game scene, or it's going to load the main menu scene, go back to the main menu. And that's it. Okay, and then there's also moving terrain, which I'm guessing, yeah. So all this really does is just pushes the walls down based on the falling speed every frame, and that's it. So again, really simple. Just need to make sure the speeds match up so that you don't end up not seeing the terrain or falling faster than it or something like that. But otherwise, yeah, pretty simple, pretty cool. So I hope you guys enjoyed this code review of a Hazel game, something different here today. It's always really interesting for me to hear your thoughts about what you thought it was like, you know, making a game in Hazel. We're trying to improve it and make it as intuitive, as comfortable as possible for a wide variety of different developers to actually use Hazel for their purposes and their needs. I haven't made too many videos like this just because, again, Hazel isn't officially out in my eyes yet, and it's not free for everyone to use. So once that happens, I expect I'll probably make a lot more content surrounding it and things like this, but it's also about the journey. So I thought that throwing something like this in would be hopefully quite enjoyable to you guys as well. As always, if you want me to review your project, then send it into chernoreview@gmail.com. That email address and some instructions will be in the description below. Thank you all for watching. I will see you next time. Goodbye.